Good morning, student. I hope you all are fit and fine. I also hope that you have gone through the topic of the last class. In the last class, I have explained what is electricity and what is electric charge and their types of electric charge, that is positive electric charge and negative electric charge, as well as the properties of electric charges, means like charges repel each other, unlike charges attract each other, charges remain conserved, neither the charges can neither be created nor it can be destroyed. All these properties of electric charges I have explained. Now student, today I am going to deal with the electric current topic. Electric current. You know student, you have seen the water flowing in a river or a canal. The amount of water flowing through the river across sectional area, if the large amount of water is flowing across sectional area of the river or a canal, this shows that water current is flowing through it. Means large amount of water is flowing through that channel or across sectional areas, then you can say that large water current is flowing through it. For example, suppose you can take a pipe also. Suppose you take a pipe of different diameter and you try to flow the water through it. If through that pipe, suppose one is of this much diameter and another is of this much diameter, and in through both this pipe, when water is flowing, means here the diameter of the pipe is more, so large amount of water can flow at a time. Here the diameter of the pipe is less, so a small amount of water will be flowing through it. So if large amount of water is flowing across sectional areas of the pipe, then you can say that large water current is flowing through it. Here diameter is less, so less amount of water is flowing through it, then you can say that low water current is here. So in the case of electricity also, see that if you take any metallic conductor or a wire, it contains one or more loosely bonded electrons. If you take any metallic conductor, it contains one or more loosely bonded electrons, and these loosely bonded electrons are free to move in the conductor. They are free to move in a conductor, and these freely moving electrons in a conductors are the carrier of electric current. So you can say that electric current is nothing but it is a flow of electrons or flow of negative charges across sectional area of the conductor. Flow of electrons or flow of electric charges across sectional area of the metallic conductor. So you can define electric current in that amount of electric charge, amount of amount of electric charge flowing through any cross-sectional area in unit time. Means amount of electric charge flowing through any cross-sectional area of a conductor, or any cross-sectional area of a conductor in unit time is known as electric current. Or in another language you can say that, or rate of flow of charge is called electric current. Rate of flow of charge is called electric current. It means that let Q is the charge flowing through the cross-sectional area of a conductor in time t. Then you can say electric current. Then electric current I is equal to what? Rate of flow of charge, means charge is Q upon time. I is equal to Q by T. Now, since I have already explained that rate of flow of charge is known as electric current, that is I is equal to Q by T. Now, let us derive this formula of electric current in terms of electron. Let N is equal to number of electrons flowing through any cross section of the conductor, and E is the charge on electron, that is minus 1.6 into 10 to the power minus 19 coulomb, or its magnitude we will take, that is 1.6 into 10 to the power minus 19 coulomb. Then the total charge Q is flowing through any cross section of the conductor, will be what? Q is equal to N into E. Q is equal to N into E, which I have already explained in the previous class. Now what we will do? We will substitute the value of Q in this formula. I is equal to Q by T. So what will be the formula? Will becomes I is equal to N into E upon T. Now the current flowing through the conductor will be number of electrons flown through the any cross section of the conductor and charge on the electron upon time taken. So this formula Q is equal to I by T will becomes I is equal to N into E upon T. This is the another formula of the electric current. If you want to write it, you can write it. Now up till here, I hope you are able to understand what is electric current. Means electric current you can define it two ways. That first is smallest way is to define that rate of flow of charge is called electric current, or you can say that amount of charges flowing through any cross sectional area of the conductor in unit time is called electric currents. And the formula you have seen, I is equal to Q by T or I is equal to N into E upon T. Now let us see the SI unit of electric current. SI unit of electric current. SI unit of electric current is ampere. SI unit of electric current is ampere. And it is denoted by capital A. SI unit of electric current is ampere and it is denoted by A. 1 ampere is equal to 1 coulomb upon 1 second. Means if you have to define how you will define 1 ampere, means in a conductor when 1 coulomb of charge flowing through it in 1 second, then you can say that in that conductor 1 ampere of current is flowing through it. So SI unit of electric current is ampere and 1 ampere is equal to 1 coulomb upon 1 second. With the help of this you can define 1 ampere. 1 ampere current is said to be flow only when 1 coulomb of charges flowing through the conductor in 1 second. Now how you will measure the electric current? What instrument is used to measure the electric current? The instrument which is used to measure the electric current is called ammeter. Is called ammeter. The instrument used to measure the electric current is called or is known as ammeter. Ammeter is a device which is used to measure the electric current. And how this ammeter is connected in the electrical circuit, I will explain what is electric circuit later on. This ammeter is connected in series in an electrical circuit. And an ideal ammeter has low resistance device. It has ammeter is a low resistance device and it is connected in series in the electrical circuit. As I have told you that the instrument used to measure the electric current is known as ammeter, and this ammeter is connected in series in a circuit, An ammeter is a low resistance device. An ideal ammeter should have zero resistance. Now, one more thing is that electric current is a scalar quantity. You have heard about the scalar and vector quantity. You have learned it in class 9th also. So, electric current is a scalar quantity. Now, one question in your mind is arising that when you see a general electrical wire or touch, you does not feel any current, but as soon as it is connected to some sources, you can feel the current is flowing through it. Why does this happen? Let us see what happens. When you take any electrical wire or conductor, it contains large number of loosely bonded electrons, and these loosely bonded electrons are free to move. They are free to move in any direction. If the number of electrons flowing in one direction of the conductor and the same amount of electron is flowing in another direction of the conductor, so the net flow of charge will be 0. Now, as soon as you connect these conductor with an external source of energy, what happens? The electrons of the conductor will start flowing in unidirectional, and this constitutes the flow of current in the circuit. This constitutes the flow of current in the circuit. Now you, as per definition, you have heard that flow of electron or flow of charge, electric charge or negative charge is called electric current. Now, but what you see here in the circuit, what you are observing, that direction of flow of current is marked from positive to negative, but inside the conductor the direction of flow of electron is this way, from negative to positive. It means that to show the direction of flow of electric current, we are considering the conventional direction. Conventional direction means, as per our assumption, we always consider positive as a higher value. So, in the external circuit, when we mark the flow of current in the circuit, we mark it from positive to negative. Means, the conventional direction of flow of current is from positive terminal to negative terminal, but actual direction of flow of current is opposite, just opposite, that is from negative to positive. Actual flow of electric current in a conductor is from negative to positive, but the conventional direction is from positive to negative. Now let us see what is electric circuit. What is electric circuit? Now let us see what is electric circuit. An electric circuit is a closed conducting path containing a source of energy, a device or element or load utilizing the electric energy. Means an electric circuit is a closed conducting path containing a source of energy. That energy is electrical energy or battery or cell, whatever we are taking, and a device or the element or load is connected to it which utilizes this electric energy. Let us see. Suppose a closed conducting path means this is a battery or cell. This is positive terminal, this is negative terminal. This is connected to a load, that is bulb, and connected to the other terminal of the battery. Means it is a closed conducting path having a source of electrical energy and a load, this is called load or the element, is connected to it which utilizes this electrical energy. Or in a simple way you can draw the electrical circuit in this way also. This is the cell, ammeter for measuring the current, and this is the load, and here you can take the key. This is a closed conducting path where the source of electrical energy is the electric cell and a load is connected here which utilizes this electric energy. This is called an electric circuit. Now, electric circuit are of two types. You know that open electrical circuit and closed electric circuit. Open means where no current is flowing through the electric circuit. Means many of the students in the board examination always ask this question in a one mark question, that draw the open electrical circuit and closed electrical circuit, and student used to always write it in opposite way. Here the word open electrical circuit, open electric circuit means, open means खुला हुआ मतलब no current is flowing through it, no current is flowing. No current is flowing means when key is open, when key K is open, then no current is flowing through the circuit, and the symbol of this is for open circuit is in this way or in this way. This is the symbolic representation of open electric circuit where key is not closed and means no current is flowing through it. Now closed electric circuit. Closed electric circuit. Closed electric circuit means closed मैंने बंद का मतलब तो यहां हो जाएगा कि कुछ नहीं हो रहा है. But in terms of physics, closed electric circuit means where the key is closed, means switch is on, and in this the current is flowing through the circuit. Current is flowing through this circuit. Through this circuit, and here key K is closed. Means here the current is flowing through the circuit and key K is closed. Here the key K is opened in this open electric circuit. And the symbolic representation of closed circuit is this. What you will see, a dot is mentioned here in a closed. And another way of representing the closed key circuit is this way. What you will see here, this line is not joined. Here no dot is here. In the closed case, the dot is given here and the line is joined. So this represents the symbolic representation of closed electric circuit, and this represents the symbolic representation of open electric circuit. So till here, I hope you are able to understand what is electric current and what is electric circuit, what is the SI unit of electric current and how electric current is measured, what is closed electric circuit and what is open electric circuit. Children, please go through this topic once again, and if you have any confusion you can ask during the questionnaire period. In the next class, I will be explaining some questions based on this topic which is usually asked in the board examination. Okay, what are the questions may be asked on this topic, based on this topic, and how you have to answer it. Till then, please stay at home, be safe, and please go through the topic which I have taught you today. Thank you. Have a nice day, children. We will meet you again in the next class. Thank you.